Okay, so 5.3, we're graphing quadratic inequalities in two variables. We're going to take what we did with graphing of the linear inequalities, and we're going to apply that exact same information, but this time we're going to do it with quadratics. So again, quadratics meaning we've got x squareds happening. So in order to be able to do that, we got to be able to graph those quadratics. We've been doing it a lot this year. We've seen quadratics showing up in a lot of the different chapters. So write this equation in standard form and then graph it. Standard form, another way of saying get it in vertex form. Another way of saying vertex form, complete the square. That's what we're being asked to do here. So let's complete the square on this one. Okay, so in order to complete the square, we need to bracket off the first two and factor out your leading coefficient. 2 bracket x squared plus x. Then we're going to have plus something minus 7 on the end. We got to figure out what that something is there. Take this number here, 1, divided by 2, and squared. Okay, so 1 squared is 1, 2 squared is 4. Okay, so we're going to add 1/4, and we're going to take 1/4 away. Now don't forget, the next step here, we need to kick out the -1. So don't forget to distribute that 2 into it. Now we have y equals 2 bracket x squared plus x plus 1/4 minus 1/4 of 2. So we've got there 1/2 minus 7. Factor this within the brackets. We know what it's going to factor to. We made it. So that's going to always factor to x. Same sign. Whatever you had right before you squared it. When you divided by 2. 1/2. Squared. Now we've got minus 1/2 and minus 7. Let's just take that on the side. Make sure we can do that. -1/2 minus 7. Need a common denominator. -1/2 minus 7 is 14 over 2. So that gives me -1 and -14, -15 over 2. Bring that back in. Minus 15 over 2. Now we have it in standard vertex completed square form. The good thing about this is we can read the vertex. The three things that we would like to have in order to sketch nicely: we need the vertex, we want the y-intercept, and we would like x-intercepts. They really help out so that we can see where to graph everything. Vertex, we read it right off of here. Additive inverse, so it's -1/2, comma, and then the same number straight as it is, -15 over 2. Y-intercept. We have the general form right from the beginning, so the y-intercept is going to be that last number. The y-intercept is when x equals 0. So plugging 0 in gives us -7. X-intercepts, we can find them by going and doing making the y equal to 0. We can factor, we can use the quadratic formula, okay? Or we can, as we have a completed square, we could just start taking everything over and solving for the x. So lots of the different ways that we've done it. Okay, so let's do a quick sketch of this. We've got our vertex. Got our grid on there. Vertex is at -1/2 down to -15 over 2. That's 7.5. And then we've got a y-intercept, which was -7. These are going by 2s, 2, 4, 6, 7. And should have actually gone a bit further over. So it's always best if you're trying to get the graph to look as close as possible to actually find all the x-intercepts. And we've done a lot of that, so I'm not going to go through that whole thing right now. All right, so we got to graph this quadratic function and then pick some test points to go through here. Really good idea is to pause the video, graph it yourself, make sure that you can graph, do completing the square, and then see if you get it right. And work through this whole thing by yourself, and then check if you got it correct with me. You'll learn a lot more from doing this by yourself. So in order to do a quick sketch, finding the vertex, let's go through that, equals x squared plus 4x. We don't have a leading coefficient to pull out, so we can just go plus something minus something, plus 1 on the end. That plus something minus something is the 4 divided by the 2 squared. So 2 squared, which gives us 4. So 4 goes in and 4 comes out. These first three, those are the ones we want to factor. That's going to factor into x, same sign, number right before we squared it, squared. Negative 4 and positive 1, we got negative 3. Done. So let's get some grids on there. I've got my vertex at negative 2 comma negative 3. So because I know it's going to be in the negatives on the vertex, I'm going to slide my lines over a bit. So that looks good. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, negative 5. 4. All right, plug her in there. Negative 2 comma negative 3. My y-intercept is equal to 1. So that means that 2 over, is that 1? So 2 over in the left from the vertex is also going to be 1. To that point. It's got to be symmetrical on either side. Okay, so we've got our 4 points, our quadrant 1 point that we're going to use, quadrant 2 point. We've got quadrant 1 point as B. We've got a quadrant 3 point as C. We're going to get a quadrant 4 point as the D. 1, 2, and 1, there we go. And then plug them into the two originals here. See which one's true. If it satisfies the yellow one here that I have, I'm going to be shading that area in yellow. If it satisfies the blue area, I'm going to be shading that blue area in. All right, so let's take point negative 2 comma 4. Let's see what happens when we use y equals x squared plus 4x plus 1. Let's see what happens to the left side and right side. Left side is going to be 4 when we substitute it in. Right side is going to be negative 2 squared plus 4 times negative 2 plus 1. And when we work that through, we're going to get negative 3. So here we know that the left side is greater than the right side at point A. Let's look at point B. Point B was 1 comma 7. Let's do the same thing exactly. Take my y and my x squared plus 4x plus 1. And let's see what happens between the two of them. 7. And then we've got 1 squared plus 4 times 1 plus 1. So it gives me on this side 6. Left side is greater than the right side at point B as well. Let's pick the point C. Do the same thing. Plug in their test case. So x squared plus 4x plus 1. We've got negative 3. We've got negative 4 squared plus 4 times negative 4 plus 1. Working that through, we get 1. So we notice that the left side here is less than the right side. And then we pick our point D, which we pick to be 2 and negative 1. And work that through. So negative 1, and then 2 squared plus 4 times 2 plus 1. This side working through gets us to 13. So again, left side is less than right side. So the conclusion that we make now is the first 2 points, A and B, we know that the y was greater than x squared plus 4x plus 1. The left side was greater than the right side. For points C and D, we've got the left side less than the right side. So now we can shade those 2 parts. Point A and B was the greater than, and I said I'd do that in the blue. So all of this section in here, we shade in blue. All this section was less than, we shade in the yellow. We could have used the same thing that you learned from last topic there, from 5.2. Less than is below. We have it y isolated on one side, so we can just say below the graph. Greater than, above the graph. So it's always a good idea to isolate your y, and then you can easily use that little trick. Same information that you had on the last type. And there is a dynamic activity that you could use, an applet, on the MathXL textbook there that you can use to go through. So the graph of y equals x squared plus x minus 12 divides the coordinate plane into 2 regions. The graph where it's above or greater than. So this is shade above graph. And you also have the other side. Again, dotted line means not equal to. Solid line means equal to. So in this one, we shade below graph. And again, equal to solid line. Okay, so this part here, which is not in your book, but takes you through again just using that test point. Okay. As we want to know, pick a test point. 0 and 0 is a great test point. That one you should be using, or any test point works. They're giving you 2 and 8 here. So as we put it in there, the left side is equal to 8. The right side, we substitute it in. 2 squared plus 2 minus 12, negative 6. So since the left side is greater than the right side, it satisfies what I asked. Is the left side greater than the right side? Yes, I would shade in the area wherever the A value was that I picked, that test case. Same thing would happen if you took a test case as -6, 4. Plug it in your left side, plug it in your right side. Your left side's 4, your right side comes to 18. That does not satisfy the inequality, so that's not where you shade. Okay, so graphing the 4 different types here that you have. Both of these first two are going to be shade above. Always want to have y isolated. These bottom two are both going to be shade below. Then, these two, they don't have an equal to, so these are going to be dotted lines. These two have the equal sign, so these two would be graphed as solid lines. All right, so we need to graph the inequality here. Okay, so in order to graph this, we're going to look at where's the vertex. Well, vertex. This is already in completed square form because there's no extra x there. So it would be at 0, -4. Or thinking it as well, to kind of remind you of all of the transformation language that we talked about, this is going to be a stretch from x squared, stretch by a factor of 3, and 4 units down. Okay, so we know the vertex from x squared would have been at 0, 0, goes 4 units down, so 1, 2, 3, 4. There now is the vertex. And a stretch by factor of 3. What that helps us do is it gives us 1 point on either side. So 1 over and 3 up. 1, 2, 3. We can only do that to 1 point. And from there, we know it's going to be a parabola shape. Now we have to figure out which way do we shade. It's saying that shade less than, so below the line. What kind of line should I have? Did I want a solid line or do I want a dotted line? And because it doesn't equal, I need to make sure that I have that as a dotted line. And now I'm going to shade below that. So everything that's below. Including these parts on the side, because that is still below as these go up and out. Test case could have also been done here. Test case that I always will suggest is 0 and 0. Plug it in. So 0, is it less than 3 and 0 squared minus 4? Is 0 less than -4? No, that is false, so do not shade where the 0, 0 is. Shade the other side of the curve. All right, question number 2. Use a graphing calculator to graph this. Okay, so let's go to our window first. Keypad standard. We always want to check, do we see what we want to see? If not, we'll adjust from there. We'll try this one out. So I'm going to graph y equals -1.5 x squared plus 2.8 x minus 3.9. Let's quickly graph that just to see what it looks like. Then we'll decide which way should we shade. So, okay, good. I can see my graph. Now I have to decide, do I shade the top of it or do I shade underneath it? Well, from here, it's indicating that I shade below this. We can also do the test point of 0 and 0, plugging it in. 0, 0, 0. Is 0 less than negative 3.9? No, that's not true. So I'm not going to shade where the 0, 0 is. I'm going to shade the other side, which was below the graph. So let's shade below. I need to enter. There's shading above, shading below. So it's going to look like that. Example number 3. Two numbers are related in this way. The sum of 2 and 3 times the square of one number is. Okay, so let's just at least do this side. I know I've got a number and another number. So the sum of 2 and 3 times the square of a number is greater than or equal to 5 minus twice the other number. Well, let's let the numbers be x and y. Define your variables. So I got my x and y. So 2, the sum, so plus 2 and 3 times the square of a number. 3 times the square of a number is greater than or equal to 5 minus twice the other number. There we go. Well, in order to be able to graph this, we want to be isolating your y. So let's get your y on this side, your x on that side. Move it around. So we'll add 2y, and then we'll subtract the 2, subtract the 3x squared, and that'll give us, at the end, let's go with 2y greater than or equal to negative 3x squared plus 3. And now divide everything by the 2. And that then gives us y greater than or equal to negative 3 over 2, or negative 1.5x squared plus 1.5, or 3 over 2. Well, let's graph the related function. So the y equals. The vertex of this is at 0, 1.5. Now, let's put that on there. 0, 1.5. 1.5. There we go. And the stretch is saying I should, again, put it on the right side. 1.5 positive. The stretch is the negative 1.5. So it's opening down. We know this is going down. And I can find the next 2 points by going from here, 1 down, and going 1.5 on either side. 1 down and 1.5 on either side. There's my graph. Do I get to do a solid line, or do I need a dotted line? This one, because it's equal to as well, I get to have a solid line. Now we need to shade. Which side do I shade? No, because it's greater than, I'm going to shade above. Or looking at the point 0 and 0. If I plugged in 0 for the y, 0 equal to plug in 0 for the x, is this true? No, this is not true. So I don't shade where the origin is, where 0, 0 is. I shade the other side, which, yeah, made sense. So now use the graph to list a pair of integer values for the two numbers. Well, all you need to be able to do is find any intersection point. Every single intersection point. There's an infinite number of answers here, but every single intersection point is going to be a set of integers. Even way down here, even down over there. And that will satisfy this inequality. So let's just pick a few that work in that area. Okay, so just picking any one of them. It doesn't really matter which ones. You can pick about -1 and 2. How about this one over here that I did? -3 and 2. Or sorry, -3 and -2. How about one in quadrant 1? How about that one? 1, 2, 3. Let's do 4. 4, 3. How about one in quadrant 4? This one here I did 1, 2, 3, -2. Any of those would work. And let's just make sure that it actually works out. I don't want to substitute it back into my original inequality just in case I did this wrong. And this is where a lot of students make their mistakes, is in writing this first inequality. So let's go right back to the information right from the question. The sum of 2 and 3 times the square of one number. So let's take this one here. The sum of 2 plus 3 times the square of the number. And that's got to be greater than or equal to 5 minus twice the other number. So, and then we've got 5 minus twice the other number. Okay. Which works out to be the same as plugging it into here, but we're again just making sure that we've written it correctly. And then that gives us 3, 2 plus 3 is 5. 5 minus 4 is 1. Is that greater than or equal to? Yes, it is. So that point satisfies it. And you can do that with all the other points as well. And then just finishing up here, discuss the ideas, just to bring together what you learned about here. How do you represent an inequality? Inequality always has to do with shading and in relationship to your function when you graph it. And finish off those 3 questions.